Hello everyone, welcome to the solution of LeetCode problem 2641 named Cousins in Binary Tree 2. In this problem, we are given the root of a binary tree and we have to replace the values of each node in the tree with the sum of all its cousins' value. So here, two nodes of a binary tree are cousins if they have the same depth with different parents. Now we have to return the modified tree. Note that the depth of a node is the number of edges in the path from root to the node. So here, let's consider the first example. The root is 5, which has two children, 4 and 9. 4 has two children, 1 and 10, and 9 has one children, which is 7. So here, for this root 5, it does not have any of the cousins. So it will become 0. For this 4, it does not have any of the cousins. And 9 is a siblings because 4 and 9 have the same parent 5. So it will become 0. And for the 9, it will also become 0. Now, for this third level, 1, 10, and 7, for this node 1, 7 is the cousin. And for this node 10, 7 is the cousin. So here, for the first two node, it will be replaced by 7. And for this third node 7, it have two cousins, which is 1 and 10. So the summation of them will be 11. So 7 will become 11. I hope you understood the problem statement. Now let's move on to the algorithm. Now, in this algorithm, we have taken this example. Now the question is, how can we basically solve this problem? This problem can be easily solved by using the DFS, but the question is how to apply the DFS. Before applying DFS, we have to calculate one thing. First, we have to calculate the summation of all of the node at each level. So the summation of all of the node in the first level is 5, in the second level is 13, in the third level, the summation will be 18. Now, we have to replace each node with the summation of all of the cousins. So the equation will be the summation of all of node in the same depth minus the root value and the sibling value. So let's see how this equation works. Suppose for this node 1, the summation of all of the value into this level, it will be 18. After that, we have to subtract the value 1, which is value itself, and the sibling value, which is 10. So it will become 7, which is this. Now, for this 7, the value will be 18, which is the level sum, minus 7. But 7 does not have any of the siblings, so we have to subtract 0. And it will become 11, which is this. And by using the recursive call into this tree, for each of the node, by using this calculation, we will modify the root value. After that completion of the BFS or DFS, we will get the modified tree. And this is how the problem gonna be solved. So the overall time complexity of this algorithm is big O of n, where n is the number of nodes. I hope you understood the algorithm. Now let's move on to the code. In this problem, we are given a function named replace value in tree, and we are given the root. So here, for calculating the summation of all of the node in each level or each depth, we are using this MP vector. And in the first DFS, we will calculating the summation of all of the node in each depth. So here in the DFS, if the root is null, we have to simply return. Otherwise, we have to upgrade the value of MP of depth will be is equal to MP of depth plus root of value. After that, we have to recursively call the DFS function into the left and right subtree with the depth plus 1. Now we have to perform the solve function. Inside the solve function, we are taking the root, siblings, initial depth, and the vector MP as the parameter. And if the root is null, we have to simply return. Otherwise, let's assume the left sibling and the right sibling value of this current root is 0. And here, if the root has the left child, so for the next call, the left sibling will be the left child value. And similarly, for the right sibling will be the right child value. So here the answer will be MP of depth minus root value minus sibling value, and we have to replace this answer into the root. Now we have to recursively call the DFS function into the right and left subtree. And when we are calling the right subtree, the left sibling will have to be passed. And when we call the left subtree, the right sibling will have to be passed. Finally, we have to return the modified root. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.